We constantly produce a lot of data, for example, via social media, public transport, and GPS. But it goes way beyond that. Daily, we upload 55 million pictures, 340 million tweets, and 1 billion documents. In total, we produce 2.5 quintillion bytes a day. To handle all these data, we can use a database to handle all the data. So let's say you're opening your own online store for computer parts, and you want to be able to keep track of all sorts of information surrounding your sales. Most people would just open up a spreadsheet and start putting in things as orders come in. Maybe it'll look like this. Ada Lovelace, our first customer. She buys a CPU. And you capture all this information. And you just record this information for each of your customers that trickle in. But maybe later, Ada buys something else, like 2 display cards. And at this point, she's moved to a bigger place to have room for another computer, so her address is different. Now, you've got redundant information, some contradicting values for your customers' addresses. And if your computer store gets enormously popular, these issues would just escalate. One day, Ada calls to ask about one of her orders, and when you pull up her information, you get 3 different addresses, all these disorganized orders, and you're not even sure you're looking at the correct customer, because there are 3 different Ada Lovelaces in your spreadsheet. You could see how this might lead to a messy situation. Shipments could get sent to the wrong place, customers might get mixed up, the wrong products get sent to the wrong people. So how could you resolve this? Instead of having just one massive spreadsheet, you can have a database system. There are 4 reasons why a database system is great for our use case. 1. Database can handle a large amount of data effectively. 2. Queries can be run to search for specific records or groups of records. 3. Validation can be used to reduce errors. Last but not least, reports can be produced from the data stored or queries ran. For the first reason, database can handle a large amount of data effectively. Instead of having just one massive spreadsheet, you separate the information into different bite-sized tables. So with our computer store, for example, you might start by creating a table that lists out all your customers, then a separate table that lists out all your products, and then another table for records for each of your orders. This separates your data you're pulling in a much more effective way. So here's what your customer table might look like. You can see we've got Ada again. But now, she won't be repeated into several different rows. Any change to your address, contact information, or even name can be updated in this one consolidated place. The product table will have all your computer parts inventory. As you add or remove items, this will be the one place where you would make those changes. And orders would keep track of every single sale you make. Now these tables, although separate, have connections to one another, and this is what forms a database. So let's look at what this interaction might look like. We'll start with a customer table. Let's say someone goes to our online store and makes a purchase. It's a guy named Alan Turing, and he's in the market for a motherboard and buys one from our store. When he checked out, he entered all his contact information, and we've recorded it in this customer table and assigned him a customer ID. Let's move over to the product table. This lists all our inventory, and here's the motherboard we wanted. We keep track of it with a few fields here, like product ID, quantity in stock, and product type. And then when Alan actually orders the motherboard, we record the specific purchase information in the order table. Here, you can see we pull in the customer ID from the customer table, so we know it's Alan. We also pulled in the product ID from the product table, so we know that he purchased this motherboard. And there's another data in here that tells us the data of the sale, shipping address, quantity, etc. It's pretty obvious that this system is far more organized than our single spreadsheet from earlier. For the second reason, queries can be run to search for specific records or groups of records. The database management system data hierarchy can be divided from a database, then table, then record, and field. To perform a specific search, one of the fields in the database are known as the key field. There are a few criteria for a field to be a key field. Data in the key field must be unique to a specific record, and the data cannot be duplicated, nor can it be empty or null. Usually, data selected as the key field are numbers, so the chance of duplication is lowered. Some key fields can be a combination of fields. For example, if I want to search for Larry Page of class 1A number 40, I will need data of class and class number to form a composite key field of 1A40. As this is unique, I can successfully find Larry. You can see that the database system do not use names as the primary key in searches because two people or items may have the same name and cannot be identified for the unique record. A unique key is required to a successful specific search. If in my database no field meets the above requirements, the database can auto-generate and assign identity numbers for each record. Other examples of key fields include driver license number, student identification number, bank account number, product code, order numbers, and etc. For the third reason, validation can be used to reduce errors. When designing a database, we can also set the data type and the field length to allow validation of the data input. Therefore, the database will automatically detect if you have typed in wrong data. For example, if you mistakenly type in letters in the date of birth field, the database system will warn and prevent us from entering that data. For the last reason, reports can be produced from the data stored or queries run. If you need to show the information to a customer or a supplier and to a report presented in a professional way, probably with the company house style or logo, the database can produce a report. Your report cards are usually produced using this way. There are many examples of database management system. One example is Microsoft Access. In Access, sorting refers to rearranging all the records in ascending or descending order, according to the specific field. On the other hand, filtering means extract a subset of the records in the table according to a specific criteria. For example, you can apply a filter on the members table to obtain a list of members who live in a certain district. In Access, there is a graphical user interface, which is a more efficient interface used to manipulate and display the data, just like Excel or Google Sheet. It provides a well-designed form that has fields displayed in a clearer and more attractive format than the database view. Furthermore, in Access, using Report Wizard, reports can be easily generated with professional and easy-to-read layout. Data could be presented in tables or queries, or in most cases, summarized. To search and manipulate data within database, queries are used to retrieve data from one or more tables that meets specific criteria. It also performs calculations and records the data on request. Queries must be written in a format that Access can interpret. One example is called Structured Query Language, or SQL, spelled SQL. The syntax of SQL statements are listed right now. Database is important with Chinese Mitten Crabs aquaponics project because the project involves a vast amount of data. We collect daily data on water temperature, concentration of different ions in the water, the amount of growth of crabs. Furthermore, our room is equipped with large amounts of equipment. The inventory of the equipment are recorded by a database management system. Thank you for watching this video. If you enjoyed it, please do not forget to subscribe to our channel and give us a thumbs up. Looking forward to seeing you again soon.